Today we will be working with word problems and fractions and decimals. So to get us started, pause the video and let's see what you remember for multiplying and dividing with fractions and decimals. Hopefully you have gotten all these the same as me. That would be getting 4.5, 17.5, 15, and 8. If you have any questions about any of these multiplications or divisions, please make sure that you ask somebody that can help you. So we're buying some almonds, and a pound of almonds costs $3.90. Jen wants to buy 4.5 pounds. How much will she have to pay? This is a multiplication problem. We're doing 3.9. We don't need to write 3.90. We can just do 3.9 and then times 4.5. And we do this multiplication. So pause the video and do this multiplication and place a decimal point. Multiplying, you should have gotten 1655, and since at the beginning we have two places, we also need two places down here, so it's $16.55 to buy 4.5 pounds of almonds. And does that make sense? Yeah, it does. It's if we bought 4 pounds at $3.90, that'd be a little bit more than $12. I guess it'd be slightly under $16 if we were doing 4 pounds at $3.90. So $16.55 does make sense. Now we have a caterer slicing 6.5 ounces of cheese into pieces that weighed 0.5 ounce each. How many pieces of cheese did the caterer slice? And we're slicing it into pieces. Those are some key words. Sliced into pieces. That goes with division. So we're taking 6.5 and we're dividing it into pieces that are 0.5 big, which is the same as doing 6.5 divided by 1/2. And I write it that way because dividing by 1/2 is actually very easy to do. It's 6.5 times 2 over 1. That's just 13. 6 times 2 is 12. Half times 2 is another 1, so we have 13. Or we could have done our long division with 0.5, 6.5, and bumped over our decimal place so that we're really doing 5 going into 65, and we get 13 doing it that way also. So important thing here is we're taking a big chunk of something and we're dividing it into smaller pieces, so that's telling us division is the operation of choice here. Now we have Chris at a bakery. He bakes 14 loaves of banana bread. He loves banana bread. And he takes 8 of those loaves and he sells them to customers. So what's he doing? He's taking 8 of these and getting rid of them. So there's 5 and 3 more. So mathematically we're doing 14 minus 8 is equal to 6. And we can see those 6 loaves up here. He cuts the remaining loaves into slices. He's slicing them apart again, so we're dividing. So he can sell the slices. Each slice is 1/7 of a loaf. So we can show this on our loaves by actually cutting them into 7 slices each. We can be a bit more mathematical about this though. We know that we are doing 6 loaves divided into slices of 1/7, and that's equal to 6 times 7 over 1, and 6 times 7 over 1 is 42. So Chris is going to be selling 42 slices of banana bread. Now we have a lot of juice. 75 cups of cran apple juice for a party. She uses 2/5 of the juice to make the punch. Okay, so I have a picture here. This is showing all of the juice. 2/5 of it are for punch. And the rest of it is for single serve. So what fraction of the cups are being used for single serve? 3/5. How many cups are remaining? Well, we have to do math to find that. We do 75 times 3/5. This is equal to 45. So now the question is, she's going to be pouring some single servings. So she's going to be serving just plain cran apple juice besides the punch into single serves that are 5/6 of a cup each. How many of those servings is she going to be able to have? Well, we're going to take these 45 cups of cran apple juice, and we want to know in how many 5/6 cups can we divide it into. So 45 times 6/5, and that is equal to 54. Andrea pours 54 single servings. So now we have some bottles, each contain 2/5 of a gallon. We're going to use them to fill a 7-gallon container. How many of these bottles are needed to fill the container with water to its brim? So I have 7 rectangles here representing the 7 gallons. I'm going to divide each of them into fifths. And what we want to know now is how many 2/5 does it take to make up the 7 gallons? So let's start counting. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 1/2. So how many bottles do we actually need? We need 18 bottles. We have to round up. If we only use 17 bottles, we won't have enough. So we have to make sure that we have 18 of these bottles of water. And what we're actually doing here as a math problem is we're doing 7 divided by 2/5, which is 7 times 5/2, which is 35 over 2, which is 17.5. So we see that we need the same amount of bottles whether we do this using a concrete model using these rectangles or by using and setting up a division problem. And our last example is for Lillian. She has a part-time job. Each month she spends 1/3 of her earnings on clothes, saves 3/8 of the remainder, and spends the rest on food. So the question is, what fraction of her earnings does she spend on food? So I have a picture here, and this dark orange part is 1/3 of her earnings, and then this represents 2/3. And then that 2/3 is divided up into 8 sections, and 3/8 is used for savings, and 5/8 then is used on food. So what fraction of her earnings does she spend on food? We can count this. There's 1, 2, 3, 4, 5, but it's not 5/8. It's what fraction of her total earnings is spent on food. So it's 5/12, because there are 12 divisions going across this entire problem. So it's slightly less than half of what she makes. So being able to come up with this fraction of 5/12 The easiest way to do it is to look at a picture or a diagram breaking down what she's earning. And now that we have that, we can decide, we can figure out how much she spends on food each month, because that's going to be 5/12 of the 540. And that's equal to $225. Or we can reason this out. If 12 units is 540, we can divide that by 12, which is 45 for each 1 unit, and then 5 of those units is our 225. So, big thing with these is digesting what's presented to you in this problem. If you're familiar with the cubes model, if we're using the cubes model, these are excellent problems that you should be breaking down by circling keywords, boxing numbers, underlining the question, eliminating things that you don't need, and checking to see if your answer makes sense. That's our cubes model. I suggest that you use it as you work through these.